So f prime of x is equal to 6x. So that will be the derivative of f of x. F prime of x is equal to 6x. So let's keep that in mind. F prime of x is equal to, actually, let's just move over here to this side of the whiteboard. And I'm going to attempt to draw a graph. Well, that's terrible, but it's really hard drawing on these writing pads. If we were to graph out, our function was 3x squared. Okay, so it would look something like this. This guy would be good for finding the tangent line at any given point on this graph. Alright, so let me attempt to draw a tangent line. Here, we'll do that in red. So at this point here, for example, let's just say this was 2. Okay? And I would draw a tangent line to this point right here. Alright, this definitely doesn't have slope 2, but this thing, you have to tilt your head a little bit. Anyway, if you were to plug 2 into the function down here, f prime of 2, you would end up plugging 2 in, you would get 12, right? 6 times 2 is 12. So this would have a slope of 12, which, by looking at this picture, this does not have a slope of 12. So tilt your head a little bit there, about 30 degrees or so, to the right, and try to get that slope to be 12. But anyway, this line right here would have a slope of 12, and this is your tangent line. Okay. I think in the next section on tangent line problems, we'll be talking more about this, but you got the idea of how to find the derivative using the definition. And that's what this main section is over. I just wanted to slightly cover how to find the derivative using the definition. Okay. Now I'm going to give you a hint that there are shortcut methods that we're going to use in the future. We can't find the derivative of a function every time like this in the future, because this is just 3x squared. What happens if this was x to the 4th power or 5th power or 6th power? Right, this thing would be so nasty we'd end up spending our whole day just finding the derivative of a function. So there's a shortcut method of doing that. Maybe you should try to find the pattern. Anyway, okay, well, I'm going to leave it at that with the definition of the derivative. And check out the next section on the tangent line problem, because then we'll put a better picture to it, and I'll use actually a graphing utility to do that instead of my great drawing. Anyway, all right, thanks.